Okay, guys. Patrick. Come on. Okay. So, I can determine how the pattern of change in a linear relation shows up in a graph, table, and equation. I would like you guys to go ahead and circle pattern of change. What is this? What is a pattern of change? What are the other words we've called this? What have we called pattern of change? It is a linear relationship, but what is it specifically? Okay. What creates your change in pattern in a linear relationship? Your rate. So write that down. What's another word for rate? Pattern of change. Constant. Your constant. We've called it that before. Okay. So the rate is what creates the pattern of change. So here I have a table. And what I'm trying to find is, how do I determine what the rate is? So, do you see a pattern in this table? Talk to your partner. Do you see a pattern?
Yes. Because the time it goes up by 1, but then it goes up by 10. And then goes up by 1 and then 10. Yeah.
Okay. So Garrett noticed a couple things. Just put it on my desk. Please face forward, okay? If you face forward, then it's a way better situation. So here I have a pattern of change. Okay, as I go up 1, I go up 1 here. As I go up 1 here, I go up 2.5 over here. So what you guys are doing is recognizing what your rate is. Now let's say I wanted to find the rate by using different numbers. I can use any of these numbers to find a rate if it's linear, Steve. And we know that these are linear. So what I do is I pick 2 corresponding numbers. I'm going to take 10 and 20. This is my x-axis. What's the difference between 20 and 10, Kaylee? What's the difference between 20 and 10? 10. So what I'm doing is I'm finding the difference, and so I'm on my x, so what's the difference? 20. I put 20 in the denominator. Then I put 10, sorry, because that's the difference. Then I come over here. 55 and 65, what's the difference? 10. What's 10 divided by 10? 1. That means Henry's rate is equal to 1. Make sure you get these notes down. So his rate is 1. We did that by finding the difference in the x values, and then we found the difference in the y values. Okay. So if I go next to Emil here, and I'm going to use the same set of data, Landon. Head up. Same set of data. I'm going to find the difference here. You already said it was 10. Then I'm going to find the difference over here. What's the difference between 50 and 25? 25. 25 divided by 10 is 2.5. So Emil's rate is 2.5.
Didn't it say this in the book?
Uh-huh. I'm showing you how to find the rate because you're going to need to do this. So that's how you find the pattern of change. That's how you determine it in a table. In a graph, it looks a little different. Okay? Turn your papers to the blank graph. I would like you to go ahead, draw a line down the middle, draw a line straight across. And then draw a line that kind of goes up, straight line, linear line, that crosses your y-axis at a positive point.
What's a y-intercept?
Let me talk about it. So how do I determine the pattern of change in a graph? It's a lot harder and it's not as accurate. So one of the things that I'm going to do is I'm going to look for an intersection like right here where it's right on the line for the x-axis and it's right on the line for the y-axis. I find those two numbers. Now your line's going to be different. So you're going to have to figure out what yours are. But if this is 1, 2, that would be 3. So I know my x value is 3. So 3 goes in the denominator. Come up here. 1, 2, 3, 4, 5. 5 is my y value. So my rate is 5 divided by 3. Oh, and what is that? That's going to be 1.333? No, 1.666. Just check it here. Yeah, 1.66. So this is 1.66. So that's my rate in finding using a graph. How do I determine my rate in a graph? That's all. I have to find 2 points, and it can be any points that are on this line. And that is going to tell me my rate. Any 2 points. Okay? I find my x point. That becomes my denominator. My y point becomes my numerator. I divide it, and that gives me my rate. That's my pattern of change. Yeah?
Wouldn't it be 1.6 seconds if you round?
If I rounded it, yep, it would be. The y-intercept, your question, Skylar. This is where my y-intercept. It's where the graph crosses the y. This is what that means. If we had an equation where it's distance equals rate times time, if I put 0 in for time, this is time. This is distance, right? If I put 0 in, what's D on this side? D is this value right here, and here it's 1, 2, 3.
Yeah.
That means I have to add 3 to that equation.
Okay.
Because when I put 0 in for time, which is here, what comes out? 3 comes out. That's what the graph tells me. Does that make sense?
That makes sense.
That's your y-intercept. Okay. You also have the notes to those questions in yours. So, in an equation, I would like you guys to write these down. Write down this equation at the bottom of your graph. And I would like you to write equations. So how do I determine the pattern of change in a linear equation? It gives it to me. This is my pattern of change. This is my pattern of change. My pattern of change is going to be my rate. This is my rate. And my rate works with my independent variable, my x-axis. It works with, up here it's time, and here is time. It's the coefficient of time. That would be the technical term. The mathematical term. So in equations, the pattern of change is easy to find because they give it to you. Or they say, Joe walks 5 meters per second. Or they tell you the donuts cost 50 cents per donut. That would be a rate. That is your pattern of change. Questions about patterns of change and rate? Skylar?
Kind of a different equation, but still about.
Mm-hmm.
So you said that in a equation you can't find an independent and dependent variable. How
I plug, so in this equation, let's take this one for instance. Here's my independent. Here's my dependent variable. How do I find them? I put time in. So I put 30 seconds in. So 30 seconds goes here. 30 times 30 plus 45. So this becomes 75, right? That's my y. My x, I put in 30. So I go to a graph, and I would graph 30. So that would be my point, right? Does that make sense?
One more.
Yeah.
How do you know if it's a linear relationship in the equation?
There's a rate. Yeah. If there's a rate, okay, you know it's linear. Because what they're saying is that that your dependent variable is changing 2.5 at a rate of 2.5 by your independent variable.
Yeah.
That's how that multiplication works.
Is the rate's independent?
No. A rate is a rate. An independent variable is different.
Okay.
A rate has 2 units. So a rate could be miles per gallon, cost per donut, shirts per person, right? An independent variable is 1 unit, time. Number of donuts. See the difference? So dependent and independent variables are 1 unit. A rate is always 2 units. It's something per one, right? Questions? Your job for today. Go ahead. You're going to work with your table partner on problems A all, B all, and C all, and D all. We're not going to finish all this today. Don't worry. You're going to have, but we need to get you all of A today for sure.
Is this A?
Okay? I gave you a sheet so you don't have to create the tables. You will need to have to work pretty hard. If you have a question, raise your hand. I can come by and help you. Use this, Landon. Use this. That sheet I gave you, or you grabbed when you walked in. It's lab sheet 2.2. It will give you a structure to start your work.